Good morning, 8th grade science students, and welcome back to week 7 and module 7.1, Stability and Reactivity. This week, I wanted to take all of the information we've learned so far and start to synthesize it with some very important concepts. So today, we're going to learn about atoms and their stability or reactivity, and tomorrow, we're going to learn how they actually form compounds, which we learned way back in week 2. At this point, you should have completely answered the do now, which is review. In today's Engage, you should have used the periodic table to learn about sodium and magnesium. Should have watched both videos to see sodium and magnesium in action and think about their reactivity and the properties you saw that showed which one was more reactive. You should have noticed that sodium was more reactive. We knew this because in the video, when sodium was dropped into water, we saw a much more violent visible reaction. More light was produced. Okay, there's more fizzing and bubbling. Those are two clues that there's a stronger reaction or a higher reactivity for sodium than magnesium. By the end of today's lesson, you're going to be answering this key question, which is why is sodium more reactive than magnesium? Something about its chemistry, something about its makeup is the reason why it's more reactive. And today you'll understand why and be able to apply that understanding to lots of different elements to understand why some are reactive and some aren't. You also read the Explore section so far. You learned the two key ideas for today. The first of which, atoms are called stable, so they're not reactive, if their outer electron shell is completely full. Okay. We reviewed that the first electron shell holds 2 electrons, the second electron shell holds 8, the third holds 8, etc. We call that the octet rule. Octopus, oct prefix means 8. So 8 electrons fit into most electron shells, the first being the exception, which only holds 2. Now, the caveat, once again, as you get into higher levels of chemistry, you'll understand there's more nuance, there's more detail there, but for the sake of 8th grade science, that is good enough for you to understand that the octet rule means there's 8 in all electron shells, except for the first one, where there are 2. Now, when we looked at carbon here, carbon has 2 electron shells, has 6 total electrons, so 2 fit into the first shell, and then there's 4 left over, which fit into the second shell. So carbon does not have a full valence shell. The second shell fits 8, but there's only 4 in the second electron shell. Therefore, the atom is not stable. We could also say the atom is reactive. The second element you saw was neon. Neon has 8 valence electrons in the second shell, so it's full, which means it is stable. So neon is not reactive. Neon gas will not react with other elements or compounds. So let's go ahead and summarize that into our own notes. So an atom is stable when? Well, when it has a full valence shell. When the outer electron shell is completely filled to its maximum capacity. So if it has 3 electron shells, the third one fits 8. If it has 8 valence electrons, it is stable because it is full. Now, we often think about elements in this way kind of as people. And so if you're stable, that means you're happy, you have your life put together. Think about some middle schoolers you know. A stable middle schooler is the one who's calm, put together, they know who they are, they know what they're all about. The reactive middle schooler is the one who's yelling at their friends, the one who's starting drama, the one who's upset about everything and hyper emotional. They are really volatile, they're really explosive, they're really reactive. So all elements want to be stable. That's their goal in their little elemental existence. And so stable elements are happy. Reactive elements, unstable elements, are not happy. So if it is unstable, it will gain or lose electrons to become stable. Once again, an atom's goal is to become stable. So if it's carbon, if it has 4 valence electrons, it's not stable. It wants to either gain electrons to become stable or lose electrons to become stable. Quick review, the first shell can hold 2 electrons. And the octet rule says that all the other shells can hold 8 valence, or hold 8 electrons. Octet 8. Now, like we just said, an atom wants to become stable. The closer an atom is to being stable, the more reactive it is. Once again, the closer it is to being stable, the more reactive it is. I'm going to phrase it this way. Think about sports for a second. Okay, I love basketball. So if you're playing basketball, it's the fourth quarter, the game's coming down to the line, and you're down by 1 point. Your team is going to be fighting like crazy to get another bucket to win the game. You're going to be fighting and doing everything you can to win the game because you're only 1 point away. You're so close to winning. If you're down by 20 points, well, I don't know. There's not enough time to finish up. We might not win. Team starts to give up. Team's not going to be working as hard and playing as hard. So atoms act in the same way. If they're really close to being stable, they really want to either gain that electron or get rid of it. So they're going to be doing everything they can to get that last electron. They're going to be very reactive. If they're further away, it's harder to get those electrons. It's harder to give away those electrons. They're less reactive. Now, let's put this into practice. How do we actually use this information into understanding some chemistry? So, first we're going to analyze this model because this model is a really good visual understanding of what I just said. So, here we have a Bohr model of oxygen as a neutral atom. Okay, it's element number 8. It has 8 protons and it has 8 total electrons. We have 2 in the first shell, which means we have 6 left over to place in the second shell. 1, 2, 3, 4, 5, 6. So it has 6 valence electrons. The second electron shell can fit 8 electrons. Therefore, oxygen is reactive. How did you know? Well, I know it's reactive because the second shell can fit 8 and it only has 6, so it's not full. It's not stable, so it's reactive. Now, what this model shows is there's 2 options for oxygen to become stable. Either it can gain 2 electrons, option 1 here. So it could gain 2 electrons. If it gets 2 extra electrons, 6 plus 2 gives us 8 valence electrons. Now it would be stable. It's happy. It's content. The other option, though, is it could lose all 6 of its valence electrons, and when it does so, notice now it only has 1 electron shell, and that first electron shell has 2 electrons in it, and it can hold 2 electrons. So now it's also stable. That's a different pathway for it to becoming stable. However, elements and atoms almost always are going to take the easiest way out. It's easier to get 2 electrons than it is to lose 6. It's easier to get 2 than it is to lose 6. Just quicker. 2 electrons are fewer to deal with than 6. So it will most likely will gain 2 electrons to become stable. So oxygen atoms will often be looking to gain 2 electrons in order to become stable. All right, so far we saw oxygen, we saw there's 2 pathways to becoming stable, and it's going to take the easiest way to become stable. Number 2, analyze the Bohr model on the right. All right, back to old review. Let's go through this. How many electron shells does it have with electrons on it? Well, the first shell has electrons, and the second shell has electrons, so 2. How many valence electrons did this atom have? Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Is the valence electron shell full? Well, the second shell fits 8 electrons, so yes. Yes, it is full. So is this atom stable? Yes, it is stable. If it's unstable, what does it need to do to become stable? It already is stable, so there's nothing it needs to do. It's not going to add or lose any electrons because it's already stable. So we're going to say Na, so not applicable, or nothing, because it's already good to go. All right, let's move on. Analyze the Bohr models below to answer the following questions. Okay, so this first one, and the second one, and the third one. We're going to go and answer all the questions below. So first one, how many valence electrons does it have? Let's count it up. Outer shell has 1, 2, 3, 4, 5, 6. 6 valence electrons. Is the valence shell full? No. It's the 1, 2, third shell The third shell fits 8 electrons, so it is not full. Is it stable or is it reactive? It is reactive. If reactive, what does this need to do to become stable? Well, it has 6 valence electrons. So in order to have a full valence shell, it could either gain 2 valence electrons or lose 6. It's easier to gain 2 than it is to lose 6. So it will gain 2 electrons. Next one. How many valence electrons do we have? 1, 2, 3, 4, 5, 6, 7, 8. Is the valence shell full? Yes. So it is stable. If reactive, what will we do? Na, it's already stable. This last one is tricky. Take a moment and look why it's tricky. This is a helium Bohr model. It has 2 valence electrons. But be careful. Yes, the valence shell is full. Remember, the first shell only fits 2 electrons. That's kind of the exception to the octet rule. So it is stable. So Na, it's not going to gain or lose any electrons. It's already good to go. It's already happy. It's already content. All right, last practice problem here. Is nitrogen or oxygen more reactive? What? That's tricky. Well, first I need to open up my periodic table here. You should already have yours open from back when you did the Explore section, but I'm going to go ahead and open mine up, and I'm going to go ahead and find nitrogen and oxygen. I see nitrogen here, element number 7, and I see oxygen next to it, element number 8. Now it's asking which of these two elements is more reactive. Okay, so to figure out which one's more reactive, we have to first ask us how many valence electrons do they have? So nitrogen is in group 5A, so it has 5 valence electrons. We know that from last week. Oxygen is at group 6A, so it has 6 valence electrons. And they both have 2 electron shells. So the second electron shell can fit 8 electrons. Nitrogen has 5 valence electrons. So what does it want to do to become stable? Well, if it has 5 valence electrons, it could either gain 3 or lose 5. It's easier to gain 3 than it is to lose 5, so nitrogen is going to gain 3 electrons to become stable. Oxygen has 6 valence electrons, so it can either gain 2 or lose 6. So it's going to gain 2 to become stable. Now remember, back in our notes, we said the closer an atom is to being stable, the more reactive it is. The closer that basketball team is to winning, the harder it's going to fight to win the game. Therefore, which one's closer to being stable? Nitrogen needs to gain 3 electrons. Oxygen needs to gain 2. So oxygen is closer to being stable and is therefore more reactive. Once again, oxygen needs to gain 2 electrons to become stable, while nitrogen needs to gain 3 electrons. Therefore, oxygen is more reactive because it is closer to being stable. You're good to move on to the check for understanding. Pause my video and be ready to go through it in a moment. All right, at this point, we're ready to go through the answers. Okay, the first Bohr model has 1 valence electron, the second has 8. The first has a full valence shell, which means it's reactive. It would lose 1 electron to become stable. The other element has a full valence shell, so it is stable, so it's not going to add or lose any electrons. It's already good to go. Chlorine is more reactive than carbon because it needs to gain 1 electron, while carbon needs to gain 4. Therefore, it is closer to being stable and more reactive. Great work today. Keep it up. Finish up the independent practice and your mastery check. See you next lesson.